Okay, I'm going to go through some tests. First of all, I have a boost converter on the output of the alternator. We're drawing 90 milliamps to the rotoverter motor. And I can probably get that down a lot less, but that's what it is right now. 4 UF run cap as usual. And we're going 1800 RPM. And what comes out of here is rectified and then run into the DC to DC boost converter right here. And what's coming out is 16.1 volts DC. Because this was about 8.8 volts DC. It's 10.5 volts AC going into it. The diodes of the rectifier knock it down to 8.8 volts DC, which is quite a knockdown. And then it gets boosted up to 16 volts. Okay, so that's what I'm testing right now. I want to test this transformer after this. We'll see if we get that far. Okay, now what the test is filling up this supercap bank. So first of all, let's see what the supercap bank is in voltage. Just 1 minute. Okay, the supercap bank, it's 80 UF, 80 UF. I mean, what am I saying? 80 farads. It's big. 80 farads. And it has 10.6 volts in DC across it, okay? Now we're going to measure the current going into it from this at 16 volts. So 1 moment. Okay, it's 170 milliamps. Alternator has really tight air gap. Oh, I need to widen the air gap, but I want to do these tests first. Right there. Okay, so the amps is now 150 milliamps, and that's the positive of this DC to DC boost converter going into the positive of the supercap. And here's how fast it goes up. Look, it just went down to 140. It's taken a while to go up. Look, it just went down to 110. Look. Now, what I can do to boost the power is put this 17.5 UF AC cap across the AC side of the full wave bridge rectifier. And when I do this, the draw goes up a little bit. And we have more amps going in. Here's without it. Take it off. The amps going in is only 110. Put it on. 170. And on the input, take it off. The input's at 90 milliamps. Put it on, it goes up to 110 milliamps. So now the next test is I'm going to turn this little potentiometer right here and make the voltage output not 16 as it is now, but take it up to 36. Okay, so one moment. Okay, it's at 20 volts. All I have is a voltmeter on the output of the DC to DC boost converter. Just a voltmeter in DC. And notice it's 20 volts, but if I take off this, it goes down to 16.1. Okay? And I put this cap back in. And now it goes up to 20. And I will now adjust, see if I can do this holding the camera. Okay, got the screwdriver in. When I turn it clockwise, there, now the volts start going up. Keep turning it clockwise. I like these little things. They're also like isolators too. Okay, we're getting it up to, I want to get it to 36. I want to do it 36 without the cap. That's weird. I took the cap off and it goes to 37. Put the cap back on. It's still 37. Let's take this even higher. Let's go 48. Let's blow something up. Oh yeah. Okay, we got 48 volts coming out of here. Now let's do some damage to the super cap. Let's do it. Now I'm going to put the voltmeter across the super cap so we can see what's happening. Voltmeter's across the super cap now, and it's 11.1 volts in the super cap. Now we're going to inject 48 volts from this boost converter into that super cap, and I'm going to have the amps going in there, showing right here, going into the super cap right here. And this is the volts across the super cap. So ready? Here we go. They say you aren't supposed to put more than 16 in there, but I think they mean that once it gets up to 16, no more. But I think you can put in 48, because I was doing 36 yesterday, no problem. But we'll see. Okay, ready, set, boom. Okay, we're putting in 48 volts. It's not any big increase in amps going in. I don't see the volts climbing rapidly. Let's take this off. Whoops, sorry about that. So it went up 0.1. Amps is 150. I don't know. A couple days ago, I had the booster filling up this super cap. Every 2 seconds, that would go up, and this was at 36 volts. It's not doing it now. I wonder if this boost converter is a little bit messed up. Here's the current potentiometer. Also, here's the draw now. So, I'm not impressed with this because the super cap's not gaining voltage very fast. I wish I'd filmed it when it worked better, but that was before. This is now. So I'm going to abandon this test. I think I'm going to have to use another boost converter, see if it's bad or something. But it sure isn't filling the cap up much. And it's at 48 volts right now. Okay, I'm going to put it on pause and I'm going to connect this transformer. Alrighty, I disconnected the full-wave bridge rectifier. Here's exactly what's coming out of the alternator. Let's put the meter in AC. And I think this is going to say 10.5 volts AC. Let's see if it does. Almost 10.5, 10.3. Okay, so this is in AC. Now also this is 240 hertz. So I can't say these meters are telling the full story, especially with currents coming out. Because it's twice the frequency of, 4 times the frequency of 60 hertz. But I'm going to guess the voltage is about what it is. Alright, let's hook up this transformer in normal fashion, parallel to the output, and see what we get in volts out of the secondary. So I'm going to put this on pause again. Okay. I'm getting 13.8 volts now out of the transformer. Remember, it was 10.3 before, and I hooked the alternator AC output right to the primary right here, the messy primary, and the equally messy secondary now has 13.8 volts, which is nice. Now, let's plug in this cap I don't know what you'd call this, a tuning cap, maybe? Coupling cap, I don't think. So I'm going to put this across the AC output. Oh, also, the draw has stayed the same when I hook up this transformer in parallel with no load on the secondary, just looking at voltage. Okay, so let's hook this up. This is now going to be hooked up to the AC. Wow. Still no increase in draw, which is surprising. I thought there'd be increase in draw. Now the voltage goes up to 16.2 AC. Alright. And we're measuring the output from the secondary on this transformer. It's kind of surprising that the draw hasn't gone up. So now I'm going to connect this full wave bridge rectifier AC to the 16.2 volts AC coming out of the secondary. And this will probably kick it down to maybe 13 or so, I don't know. So let me put you on pause again. Okay, well, I have the full wave bridge rectified. I have the meter in DC now. And we have 14.1 volts, which is just what I was aiming for. So I guess my ratios of lines is good. Now I have this DC output from the full wave bridge. Let's put it into the super cap, see what happens. I don't know what's going to happen. Okay, hold on. Here is the super cap voltage before I hook up the output of this transformer rectified into it. And it's 11.4 volts. Okay, hold on a sec. Okay, here's the super cap, 11.4 volts. And the full wave bridge is connected to it. And I don't see it going up too fast. The draw went up from 0.09 to 0.1, 90 to 100 milliamps. I see not much at all. I'm going to see what the current is. I bet you it's not much. Yeah, we're only seeing 90 milliamps of current going into this super cap bank from the output of this transformer in parallel. And I have this cap over here. Let's disconnect the cap and see what happens. Now the draw has gone down, the output amps has gone down to 70 milliamps. While the super cap bank did go up 1/10 of an amp. So it's 70 milliamps, 6, I see it dropping. Okay, let's go with this. Still no great voltage rise. Now it's gone up to 80 or 90 milliamps into the super cap bank. And this is still not too good. This is the voltage rise of the super cap. So, everything right now is not working like I'd hoped, but you never know what to expect. check my alternator. Just one moment. Okay, alternator's 10.3 volts coming out of it. Let's see what the amperage is. Crowbarring, but putting an ammeter from here to here. See what that is. Just wondering. Okay, it's excellent amperage, 1.9 amps. Putting a meter in AC right across the output of the alternator. However, that boosts the input up to 160 milliamps. But it has capability of making a lot of amps. Let's put this cap across here and see what happens. Same amps, same draw. Okay, I'm going to measure the DC out coming here again because I think I had my meter in AC, not DC. So I'm going to do that again. We're going to look at the amps in DC going into the supercap bank from the transformer into the full wave bridge. Okay. Here's how fast the supercap bank goes up. You know, I was saying every 2 seconds. It's 0.1, but I think it was every 2 seconds it's 0.01. I had before, because that's what's going on now. About every 2 seconds, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 5 seconds. Wow, look at the crappy amps in DC coming out of the full wave bridge rectifier. This is conventionally hooking up the transformer in parallel on the primary to the AC input, which is what comes out of the alternator, and parallel to the full wave bridge rectifying the DC and feeding it. So let's try something different here. I'm going to do that vector stuff, a series. We're going to series this. So one moment. Okay, wow, that really helped. Something went right. Okay, what I got here is the AC output of the alternator. Like what I drew in the sand a couple videos ago. One AC leg of the AC input, which is the alternator, goes to one side of the cap. The other side of the cap goes to one leg of the primary. The other leg, I guess you'd call it, is going to the other AC leg here. Now what's good is we've only raised the draw from 90 milliamps to 110, and we now have 170 milliamps pumping into that supercap. Isn't that nice? And I just picked a 20 UF cap. Now it's going like, let's wait till 1 Mississippi, 2 Mississippi. Yeah, every 2 seconds. seconds, so this is a good rate of charge. Very good. To this 80 UF SuperCap. So, I'm a little tiny bit happy. That vectoring transformer is really working, because if I paralleled this and paralleled the primary with the AC input, all I had was 60 milliamps going in there. Now I have 170. Let's take a 9 UF cap. I'm just going to put this on it. Oh yeah. 9 UF added, so it's 29 UF. It's now 210 milliamps going in. Wow. Instead of 170. Although the draw goes up. But not too bad of draw going up. We're getting the volts up around 12 now. Let's try a 40 UF cap. Oh, what's this going to do? So this is a 20 and a 20. Does that say 30? What does that say? I'm going to use jumper cables. Hold on a sec. No, 40 UF kills it. It drops it down. It drops down to 160. So I think this is a sort of like a resonance thing going on with this cap. It's in series between this inductor and the AC input. So it's kind of working like a resonance cap. So what was it? 29 looked good. Let's try 25. So this will be a 5 and a 20. One moment. Okay, 25 is good too. It brings it up to 200 milliamps being pumped into the SuperCap bank. And again, it's every, oh, see the way it drops there? Oh, it's dropping, now it's going back up. And it recovers itself and continues to gain. So 29 UF was 210 milliamps going into the SuperCap bank, although it raises the draw. Now I have 20 UF, 170 into the SuperCap bank, and the draw has gone up from 90 to 110. So I like this transformer now, and I like hooking it in series, so it's a vector sort of way to do it, as I drew in the sand. Okay, so you know what I want to do now is an experiment. Last time I did this on video, it made the motor stall immediately, just chonk. And that is, you put a 20 UF cap between the AC feed line, between line 1, so it's going to go right in between here. Actually, I'll put it down here before the current meter, so we won't bypass the current meter. So I need to hook this up from red to black in series. And also, I want to have this filled up in voltage before I do it, because I think last time this was like at 0 or 5 volts or something. And when I connected it, it just made a big magnetic break. So hold on a sec, I'm going to make sure this is filled up and measure the voltage inside of it. Okay, this is interesting. I have a 20 UF AC cap, oil filled, like I use for rotoverter use. And I want to fill it up before I connect it in series like I was just showing, but you know what? It certainly does not keep a charge very well. I guess that's just the nature of these. Okay, here we go. I touch this wire. I just have it plugged in here. There we go. It's all the way up. Now I take off the wire. Ooh, it just drops right down. Interesting, eh? I have it in AC. I thought it would hold a charge a little better than that, but it doesn't. Okay, well let's try hooking this up like I was describing, and it's probably going to be the end of the experiment. If it works, it'll work. If it doesn't work, it's going to like break that fail-safe taped connections on the shaft between the alternator and the motor like it did before. So let's see what happens. Okay, hold on. Okay. This wire and this wire go to the cap. So when I disconnect this red clip from that black clip, it's going to have this cap in series. So I'll squeeze this and pull it away and be ready. This might just go on. One, two, three. Yeah, hit it. So, I don't know, I've got this to work before, and it didn't do that. I don't know what it is. So that's the end of the experiment today. Very hot day, it's like 90 degrees it feels like. Unplug everything. I'm waiting on diodes to repair my stat power inverters. I have ultra fast diodes that are supposed to go in there, and I do have another one, a little larger version, this one here, and this one works really good, but you know I don't want to sacrifice it right now. So I'm just doing tests with using the 120 volt grid. Okay, well, now I want to make a much wider, not much wider, but a wider air gap to this, because there's a lot of copper these magnets pass through, and it creates a lot of eddy currents, and it slows it makes it harder for the rotoverter to push itself, to push those magnets past everything, just with no load on it. And I have other ideas, but I'll go into that later. So, okay, this is, okay, in summary, this worked good, especially in vectored mode with a 20 UF cap, and even better with a 29 UF cap. And I guess that's it. Okay, thanks for watching.